need the blackboard, so I'll just read you. So the first question is, what is the maximum current? So let me just see if I can have this make some sense. So I'm going to put a voltage here. And as that voltage rises, the current's going to rise, and then it's going to reverse. And so the field is going to be rising, and then falling and reversing. And so there'll be a magnetic field that oscillates. And that means the flux through this coil is oscillating as it oscillates. And everything is going to be according to the same period and the same frequency. And so if this is the maximum voltage, the I max, the maximum current you're going to get, is simply the voltage divided by the resistance. So if we take an oscillating voltage is on the larger outer coil. So the outer, I should have written all this down, is 800 for N, a diameter of 6.4, centimeters, and a length of 12.2.
That's going to be more. This is twice this. Yeah.
And a resistance of 4.75 ohms. So that's the outer coil that we're driving. And then the inner coil that's subject to this changing flux is 1,000. Wait a minute, did I screw up? I got them reversed. Well, that'll be easy to change. So the secondary coil is 1,000. The secondary coil is placed inside a larger. So that's the inner. So this is 1,000 turns. 9.6, 14.4. Yeah, that's larger. And the R is what? 5.21? So anyway, the voltage we're applying is the 12.8 volts and the 5.24 ohms, and so that will give us the maximum current. And since the current follows the voltage, we can write that the current through that outer coil is going to be simply, do you have a number for that? No. Whatever that number is.
2.44 ohms.
No, it's going to be amps.
Amps.
Is it 2.44?
Both over ohms. Yes.
So 2.44 amps. And it's going to oscillate the same way. So it's going to be cosine 2 pi t over 60 milliseconds. That current is going to lead to a field. And the field, the B, for a coil is mu naught N over L times I. So now you have to do mu naught N over L times this I, and you'll get a number. That will be the B max. And the V max is going to follow the current. So the current follows the voltage and the field follows the current. And so let's not try and get that number, but let's just say it's 18 something. Then it's going to be 18 Tesla. Well, it's more likely
Probably just put
0.018 Tesla to say it is. Same thing, times the cosine of 2 pi t over t. Okay, but now you're going to use the field to get the flux. So the flux is B A cosine theta, or flux max is going to be B max. A is fixed, and the cosine of theta is, they're lined up, right? Coils are lined up, so the cosine of theta is 1. And you say, well, couldn't it be 1 or -1? Well, as this oscillates, it will automatically switch. So this is 1. The area comes from the pi r squared. And so the flux max is going to be this number times the area times 1, whatever that ends up being, 0.0694, whatever it is, and that's going to have units of Tesla meters squared. And that will oscillate. The flux is going to oscillate, right, according to the same function, cosine 2 pi t little t, time variable over the period. And now that you've done all that, now you can use Faraday's law to find out what the EMF on the other coil is going to be. So it's minus N. This is the inner coil times okay, there's one place you're going to derail. You want the flux through the inner coil. We want to get the voltage output here. So the field is from here. Right? We get the field. But we want the flux through this. So we got to use the area of this. Because this is where we're getting the output. And that's just 1 because they're lined up. And so if that's, so this will be the flux through here. Now you go to this. So the number of windings on the inner coil. And you're going to take the derivative now. Now you do have to do, for the first time I think, since because it's actual, do some differentiation. Where you're going to take the derivative of whatever that is, 0.0, whatever it comes out to be, Tesla meters squared, cosine 2 pi t by dt. So the derivative of the cosine is a negative sign, but a 2 pi over t has to come out. You can remember how to do that. And that will give you, multiplied by n, will give you the EMF output. And no surprise, the output is going to be something in volts. Let's say it's 16.9 volts, but you're gonna have a sine function because the cosine differentiates the sine. Anyway, just to bring this back to something. So if you put in something that's a cosine, notice you start out, the cosine is flat. So the function isn't varying here. And so what you have for an output is you start at 0. There's no voltage output because it's not changing. When you go a quarter cycle, you're at the point where this is changing at the maximum rate. And so you go to a maximum negative output. Then it goes back to 0 output. Then it goes back to a maximum positive output. And then it goes back to 0. You see you get a negative sign. So the differentiation of the cosine goes to a negative sign mathematically, and physically it makes sense in this circuit, physically, because of what we know about Faraday's law. Oh my gosh, that was painful. Well, I hope you got something out of it. Come and see me later, I know.
Are you videoing this?